And I have the pleasure of introducing Dr. Josh Wild. I'm going to read his bio and then welcome him up here. Dr. Wild is a senior researcher in the Nuffield Department of Population Health at the University of Oxford and a research scientist in the Population Research Center at Portland State University. He is currently one of two editors-in-chief of the Population and Development Review. He's also the co-chair of the IUSSP panel on COVID-19 fertility and the family. He recently has received a €2 million European Research Council grant with which he will lead the sex ratio project at the, can you help me, what's the name of the center?
Lever Home Center.
Lever Home Center for Demographic Research at the University of Oxford, which aims to study the determinants of natural sex ratios at birth. His research is in the field of demography, demographic economics, and development economics, with an emphasis on the causes and economic effects of fertility change at both the macro and micro levels. His focus is on four major research areas: the macroeconomic effects of demographic change, particularly the demographic dividend, 2, the climate change and fertility, 3, health stocks on fertility and prenatal mortality, and 4, gender discrimination and birth outcomes. And before coming to Oxford and Portland State, Dr. Wild was deputy head of the Laboratory of Fertility and Wellbeing at the Max Planck Institute for Demography in Rostock, Germany, and an assistant professor of economics at the University of South Florida. And he got his PhD in economics from Brown in 2011. Please join me in welcoming Dr. Wild.
Let's see, got to share first, right? All right, and then here and here. Okay, good. Yeah, my vision wasn't as good as I wanted it to be there. Well, thank you. That was an excellent welcome. I'm really happy to be here. So yes, I am at Oxford, but I'm also at Portland. So fortunately, I wasn't that far to come. But I'm happy to be presenting my research here. As was said before, I have a few different research streams that are all kind of related. They can all be described as fertility generally. But today I'm going to be giving a talk on one of my research streams, which is climate change and fertility. Now, a lot of times in these seminars, you come and you listen to like one paper where you go in depth on, a specific research project that the speaker is working on. This is not going to be what I do today. What I'm going to do today, it's going to be more like a graduate lecture where I describe a field of research, how it evolved over time, what we know about climate change and fertility and what we don't know. And then I'm going to fit in like 5 to 7 of my own papers, just to kind of highlight how me and my team and my group that I have and my co-authors are filling gaps in this area. And then at the end, trying to explain what we still don't know about climate change and fertility. So it's going to be more high level than in depth, but I hope that works for you guys. Okay, so as was mentioned in the introduction, I'm a co-editor of a journal. And when people come to us and they say we'd like to do a special issue or we have a paper that we'd like to publish, sometimes we ask ourselves, does this relate to something we call a megatrend, right? So what is a megatrend? A megatrend to us is something that is a trend that has an effect on a global scale. So at this particular journal, we really pride ourselves of having papers that are relevant in large numbers of contexts for large numbers of people in different fields. So we kind of have this big picture idea, or we want to emphasize these big picture questions. So what are two big megatrends that are happening in the world right now? Well, one is climate change. So no matter where you are or who you are, climate change is something that is affecting the entire planet. And there will be impacts, more for some people, less for others, but it is going to be affecting all of us. Another mega trend is demographic change, and more relevant to this presentation, fertility decline. So all across the world, over the last 50 years, we've seen large declines in birth rates in both countries that are high income now and in countries that are low income. There are some areas of the world where this decline is stalled, such as sub-Saharan Africa, but in nowhere is fertility rising. So we see this big move toward from high fertility to low fertility, and it's been all across the world, not uniformly, but it's affected most regions. So this project is combining these two megatrends and seeing how they interact. How is climate change going to affect these demographic changes that are happening, with an emphasis on fertility? Okay, so now when we want to get into how climate change is going to affect for demographic processes, we should probably define both of those things, right? So what is climate change? So I like to think of it as two smaller subsets. So you can think of climate change as adverse weather events. So these are floods and hurricanes and tornadoes, desertification of soil, wildfires, these types of things. They tend to be specific events that you can look at them before and after, and you can see the impacts of those things. But then there's also these gradual processes. I said desertification, that's actually a gradual process, but these are like temperature change, sea level change. These types of things are gradual. We kind of want to know the effect of both on these demographic processes. But as you can probably tell, one is going to be easier to figure out what the effect is than another, because it's really hard to figure out the effect of a gradual process if lots of other things are gradually moving as well. So for example, incomes rise slowly over time and temperatures rise slowly over time. So it's going to be really hard to disentangle the independent effects of both. Whereas if you know that a hurricane went to that area at that date, it's easier to identify the effect of how that event affects these demographic processes. Now, I'm focusing on fertility, but there has been research on other demographic processes. So generally, we know that climate change, heat in particular, affects mortality negatively. But over time, it's actually becoming not as acute. So yes, the temperature is rising more over time, but people have been able to become better at adapting over time. So they have more air conditioning. So you have this weird effect of climate change is getting worse, but the demographic impact of climate change on mortality is actually getting less bad. Migration is also this kind of like interesting mix of effects, because climate change generally can hurt people's well-being, their livelihood, maybe they move away, but it's actually this complex process because the poorest of the poor aren't able to move because they don't have the resources to move. So actually migration has this heterogeneous effect based on who you are. If an adverse event or climate change happens and you have the resources to move, you move, but if you don't, you're actually stuck in the area. So we kind of know a lot about this already. There's been a lot of papers written on mortality and migration and climate change. But fertility is more of a black box. I would say really good high quality studies about fertility and climate change have only, especially the ones that I'm going to talk about today, have only been really around for less than 10 years, maybe within the last 5. So we're starting to know more now, but it is kind of like the least studied of the 3 major demographic processes. Okay. All right, so just to kind of highlight how some of my research has played into this, this field so far, I'm not going to talk a lot about these adverse weather events in this lecture. I'm going to talk more about temperature and these gradual processes. But I would like to highlight, so this is Susie Lee, one of my co-authors. She led a systematic review on these natural disasters' effect on fertility. And so it was published in the Proceedings of Royal Society B. And we're pretty proud of that work. And interestingly, we found that natural disasters have more negative of an effect, as a lot of people have noted in the literature. So there was this kind of idea that if a negative or like a disaster happened, say a tsunami in Indonesia, it would kill kids. and then fertility rates may increase through a replacement effect. We actually found that when you do the systematic literature review, there's very little evidence for that across regions. So one surprising thing that came out of this literature was actually how almost uniformly negative these effects were and not positive at all. Okay, so in this talk, I'm not going to talk about natural disasters. I'm going to talk about temperature. So this is one of these gradual processes, which is going to be important in climate change. It's going to be one of the major ones. And we want to know how that change in temperature is going to affect birth rates. I like this figure. It shows the change in temperature above 1950 for the last 4 years, because it shows that the changes in temperature are heterogeneous across the world. So I'm from Alaska, and Alaska is very red. And so I've been able to observe just in my own life how temperatures have changed just from my own lived experience. So for example, when I was a kid, I think there were 3 times in my whole 18 years of growing up in Alaska that it got above 80 degrees in my hometown. And now it gets above 80 degrees about 5 times every year. So we've been crossing these thresholds. And it's kind of like very visual and real to me that climate change is happening, and it's pretty acute. So in this talk, again, it's an overview. I'm going to talk about what we know about the climate-fertility relationship. I'm going to go into specific papers and show you the actual evidence and talk about why we know what we know. And by so doing, I'm going to say what we actually don't know. Okay, so in order to I'm going to start this presentation by talking about what the effect is. And I'm not really going to talk about why so much. Later on in the presentation, I'm going to talk about the mechanisms behind it. But just to kind of provide a framework for what you're about to see when I show you what the effect is, the magnitude, let's talk very quickly about some of the mechanisms that could be at work. And then I'm going to return to this exact slide about halfway through my presentation in order to go into things mechanism by mechanism. So I like to divide them into kind of 2 broad categories, ones that I call biological effects and others that I call behavioral effects. So biological ones are, let's say people are living their lives, not changing their behavior, but a heat wave comes and it affects them physiologically. There's some biological effect of heat that is going to cause them to have children at different rates. So they could have spontaneous abortions, miscarriages, they could lose their fetus, they could have stillbirths, or it could prevent them from getting pregnant. So there could have been a conception if they were kind of like more fertile. That doesn't happen because the heat stress or whatever mechanism causes them to not be as fecund as they would have liked. Behavioral effects are when people actually change their behavior in response to the heat. So you can imagine that people might change their sexual activity if it's very hot outside and they don't have air conditioning or some other way to mitigate the negative effect of the heat. There could be partnership dynamics, especially, we had COVID. I don't know if you'd say that was a natural disaster, but if people are hunkering down at home, that might affect partnership formation. It may move it online, or it may just affect it in different ways. So heat waves or temperature change could affect partnership dynamics, and it could also affect contraceptive use, not only in the availability of contraception, but also in the method mix that women and couples choose to use. Okay, so in the beginning, what was the very first paper that looked at the effect of climate change on fertility? Well, in order to understand why people started looking at this question, it's kind of important to understand the field of economics, because most of the people who looked at this at the very early stages were economists. So in the late 1990s and early 2000s, there was this causal inference revolution in economics where almost every paper that got published had to have some sort of causal claim. So that started in the late 90s, and I started grad school in the mid 2000s, and everyone was saying, don't think of a research question, think of some sort of source of exogenous variation. And once you found that, figure out what question you can use that source of variation to answer. So it's very backwards to, I think, a lot of how a lot of people do research. So, me and all of my colleagues there, my fellow grad students, we were just trying to think of these exogenous sources of variation. One of the very first ones that people thought of was actually weather, because there is a random component to weather. So if you can strip out seasonality and some of these other effects, day-to-day weather is random. So we had this joke in grad school that we were going to identify the world with rainfall, right? There was like hundreds of papers that came out which use rainfall as an instrument for everything you can imagine. And it's because they were searching desperately for these sources of exogenous variation so they could have causal claims for their research. So climate became in the mid 2000s, lots of economists started using climate. Different climate variables to explain stuff. So the very first paper was a paper from Lamb and Myron in 1996 in demography. So again, they were these economists looking for causal inference, and they actually did not frame their paper in terms of climate change. They wanted to explain seasonality because they saw these big patterns in seasonality in births in the US and in other places, and they noticed that if you take the temperature 9 months before, it aligned very well with the patterns of seasonality that they saw. So they ran a model, which actually was the first one to strip out seasonality generally to identify the month-to-month variation in temperatures. And then we're the first paper to kind of claim that they had a causal link of temperature to fertility. And generally they found a negative effect. Their unit of observation was the state month in the US, but they also did it kind of country by country for other countries. So it wasn't very comprehensive, it wasn't very fine, but it was kind of like the first attempt. And then interestingly, nobody followed up for 20 years until Bareka et al. In 2018, which kind of was amazing to me. So I remember I was a grad student and I was looking for a paper and I was like, I'm going to write this paper, the temperature and fertility paper. I found the Lamb paper and I was just like, oh, and I put the idea in a bin. They didn't pursue it. And then in the mid 20-teens, I was an assistant professor at the University of South Florida. And one of the co-authors of this paper was an assistant professor at a university about an hour away. And so I started writing this other paper that didn't look at the effect of temperature on climate, the effect of temperature on fertility. But I said, if temperature does affect fertility, like Lamb and Myron had said, then maybe there's these compositional differences. So I started writing this paper about compositional differences to explain later life outcomes. So that paper was, if you were conceived under a heat wave, then when you're 40, you have different levels of education as people who are not conceived under a heat wave because of compositional differences. So this other professor comes and I share this research idea and her face just goes white. And she's just like, somebody already wrote that paper. She hadn't heard of the Lamb and Myron paper. Turns out she was writing the exact same paper. So they kind of had to reformulate the paper after learning that it had already been done into the paper that I'm going to show you now, which is by far my favorite paper that's ever been written, of all time. It's amazing. And I'm going to refer to this paper multiple times in this talk, just because of how great it is. But it's very innovative. They were first to show these nonlinear effects. They looked at these 24-month spans to look not just at 9-month lags, but very long, month-specific lags. They introduced this really great month of binning, which I'm going to explain later. But it allowed them to get at heterogeneities and nonlinearities in this very nice non-parametric way. I gotta figure out if I'm going too long. Okay, so this is a figure from one of their papers, and you can see 9 months before birth, temperature 9 months before birth has a very sharp negative effect on the birth rate 9 months later. Also at month 10. Okay, so that's going to become important. So the month of conception, but also the month before conception, seems to have a very strong and negative effect. But there's also other interesting things about this figure. So for example, at lags 11 and 12, you see positive effects. So this is like recuperation. So they were one of the first people to show that if you didn't have a birth because of a heat wave, you recuperated those births later. They also have really interesting, if you look at the 21-month lag, so that's 12 months after you would have gotten pregnant. So let's say you really wanted to be pregnant in the summer and you missed, you would wait until you're pregnant and then be pregnant during the next summer. And if you look at the 0 lag, they see a sharp positive effect. So this is the effect of heat on people going into labor, right? So if you have some sort of heat or health shock, you might go into labor early because of that stress on your body. So I love this figure because it tells so many stories in a single graph. And it kind of formed the foundation of all the other papers that people wrote on this topic later, because most of the other papers just confirmed again and again and again the same things that Alan and that Bareka et al. Found in this paper, but just in different contexts. So really important, great seminal paper. Here's a figure that shows the nonlinearity of temperature. So the horizontal axis is temperature, the vertical axis is a measure of the birth rate. And you can see that up to 70 degrees, there's really no effect. But as soon as you get over 70 degrees for the mean temperature in a day, there's this exponential decline in the birth rate. So these nonlinearities have also become like a staple of the effect of climate, of temperature on fertility that most papers will also find. They were the first ones to find it. Okay, so that's great. We answered the question, right? Temperature reduces birth rates. But there's reasons to believe that this isn't the end of the story, right? So the US, they did this in the US and they did it well, but the US is kind of not a standard country, right? So for example, it's very high income. And you could imagine that in places that aren't as well resourced, would suffer the effects of heat more acutely than a place where people have lots of resources. Also, we know that climate change impacts may have larger, like in magnitude, temperature deviations in low and middle income countries or countries around the equator, and the US is not one of those countries, so we might expect bigger effects in other places. In addition, there's lots of air conditioning in the US. Put income aside, Europe is rich as well, but they don't have a lot of air conditioning. The US has tons of air conditioning. And so basically, Bareka et al. Found significant effects in precisely the place that you would guess them not to occur. So after this, people started looking in other different types of contexts to see if the results would replicate. So I caught myself when I said large effects. I should have said statistically significant effects. I'm going to get into more on effect size later, but if you take the results and you ask the question, based on what we know about climate change and how it's projected, temperature and how it's projected to change over the next 50 years, what do their estimates imply about the change of the birth rate in the next 50 years? The answer is a reduction of 1 to 2%. Which is very statistically significant, as you saw in the figures, but that's in magnitude, it's not actually that big. So if you're kind of the US and you have a TFR of 1.7, and I tell you that climate change through temperature is going to reduce TFR in the US from 1.7 to 1.68, most people are going to say, well, that's not really a negative effect. So there is an effect. It's very statistically significant, but maybe it's not significant in magnitude. Okay, so after this, there are a series of papers came out. So Cho was next to write a paper, and they wrote it in South Korea, but South Korea is also strange. It's high income, and it also has very high AC penetration. So yeah, it's not a Western country, but it's still very similar in the US in some contexts. Then Feed et al. Wrote a paper in Sub-Saharan Africa, but they didn't do the month-by-month thing. They just look at annual shocks. So it was very coarse and very crude. And they actually found increases, which kind of blew people's minds. Like, why would that be a thing? And then in 2023 and 2024, a large number of papers started coming out that just looked at a bunch of different contexts, including one. So I highlighted the papers that I was a part of. So Kozani et al., which I was a co-author, and I'll show you the figures for that later. But we did one in Spain. Hajdu and Hajdu did it in Hungary. And Marteletto et al. Did it in Brazil, and I'm sure there's other papers that may have come out since that I'm just unaware of. Another one of my working papers that I'm going to talk about now, like the very next slide, is I do a cross-country thing using DHS data in low and middle income countries. And I am very excited about this project for reasons that I'm going to explain soon. Okay, so this is the group of co-authors that I'm working with. So Yasmin is a PhD student of mine at Oxford. Raya is actually the other editor, Population Development Review. We weren't selected as a team, that was random. They didn't know we worked together when they chose us. But she's also works a lot on climate and environment impacts on demographic processes. And then her PhD student, now a postdoc at UCSD, Anna, is someone who does our data work for us. Okay, so why am I excited about this paper? Well, it's because it's global. We look across the entire globe at all lower and middle income countries, as long as they're in the DHS. We have individual level data. We're not just looking at aggregate birth rates, which a lot of these papers do. They look at like, a county and the birth rates by county. We actually have data on individuals because it's the DHS. And we have so many observations that we actually can compare results using woman fixed effects without woman fixed effects. So now if you think that there's some sort of selection happening based on different women having children under the influence of heat versus not, we have a specification where we can actually control for all that. So anything that's fixed across the woman over all of her pregnancies, we can control for that and get rid of kind of this like idea of selection that different women are having children under heat versus not. And then we can compare the size of the effect under the two different assumptions with and without woman fixed effects. So we use temperature data from NOAA. It's gridded. And we're looking at the number of days per month where the daily mean is within a 5-degree temperature bin. We're using, as I mentioned, the DHS data. We have 2 million women, and we use a 10-year woman panel. So every woman has 24 observations. You follow them over 10 years. And so we can look over multiple births and use this woman fixed effect. So this is a very comprehensive way to ask this question that's never been done before, which is why I'm so excited. It's also very computationally intensive because we have 195 million observations and 2 million fixed effects. So each regression that I show you takes 2 or 3 days to run on the supercomputer. So it's very, very comprehensive. It's very intensive. But I'm very excited about the project and what it can tell about this question. Okay, so I mentioned that the Barreca et al. Paper introduced what I was calling this binning method. So I'm going to go into that a little bit more to explain what the method is and why it's great and actually why it's not great in some respects. So we want to strip out seasonality. So if we have a dependent variable, which in this case is a 0-1 indicator for a birth, and we have, again, the 120 observations per woman, because 10 years, 12 months. So we've got, for each woman, we have 120 observations, mostly zeros. And if she's had 3 kids, there's 3 ones in that vector of 120 observations. All zeros except for a couple ones. So we want to control for seasonality. So this alpha term is a region month specific fixed effect. So if we're thinking about what this regression is doing, we're going to compare temperatures in Seattle in January against other Januaries in Seattle. So not only is it adding a control for the region, but it's also a month specific control for the region. So we're really doing this apples to apples comparison of all the Januaries in Seattle, so that if one January happens to be hotter than another January, that's the variation that we're using to identify. We also have a woman fixed effect. Lots of those. So this is we're killing all the statistical power that we possibly have here, but we have 195 million observations. So we're probably okay. We also have a country year. Fixed effect, just because births may change by country and over time. So we have a fixed effect. So we're getting rid of a lot of sources of variation here, but by so doing, we feel that we're actually getting at the real causal estimate by only identifying off of a very specific random component of temperature. So now we have this double summation. So what is this? So 0 to 15, that's 15 monthly lags. So we're going to look at the effective temperature at the time of birth, the month before birth, 2 months before birth, 3 months before birth, all the way to 15 months before birth, separately. And the G here, yes.
C is the birth month, or the, what is the month? Am I giving you a month of the temperature? I'm trying to get like.
Yeah, so we have, okay, so you're asking what the T is? Okay, so C equals month. Oh, sorry, that's a typo. Thank you. C equals country. C equals country. Yeah, thanks. I apologize. I wasn't as quick as I wanted to be. Yeah, that is very strange math. I have to agree. Yeah. Apparently I need to go back to elementary school. Right. Yes.
And by region, you mean administrative region or do you mean cluster? I guess I didn't know what scale.
Yeah. I actually forget, to be honest, in this specific paper. Some of the papers I write, we use the cluster, and some we use the DHS administrative, like the lowest level administrative region. It's different. It's at least 2. There's different for different countries because the DHS will have it, but it's whatever the lowest level one that we can get. So yeah, I can't remember if it's the cluster or if it's the DHS for this specific paper because we've done both in different papers. And so G is all of our bins. So we have 5-degree temperature bins. So we have some sort of reference bin. Let's say it's 15 to 20 degrees. Then we have a separate temperature bin for 20 to 25, 25 to 30, 30 to 35. And what these bins are is the number of days in a month that the daily mean temperature falls within that bin. So the sum of all of the bins for a month equal 30 or 31, or 28, depending on the number of days in the month. So the interpretation of each of these coefficients is the effect of one additional day in that temperature range relative to whatever our reference bin is. So this is actually nice because a lot of the IPCC projections say we expect the temperature distribution to shift in this way. So we can see the estimate of how many days in how many temperature ranges there are, and we can just plug these estimates in and kind of like find the effect of aggregate climate change. And also, temperature, it's kind of a hard thing to wrap your head around. So kind of telling someone one additional day in this temperature range is going to have this effect. It's a little bit, it's intuitive. Another way that people look at this is they look at like a 90th percentile day or a 95th percentile day. And that is kind of, I personally don't like that measure because I find it less intuitive, but also it assumes that there is no adaptation because they assume that the number of 95th percentile days will increase over time. But if there's adaptation, then the number of 95th percentile days will just be 5, right? By definition, if there's adaptation. So I don't really like the percentile way. That's why I like this meaning. I think it's more intuitive. I think it doesn't assume zero adaptation. And you can do this cool stuff with nonlinearities, as I've mentioned before. There are drawbacks. One drawback is you kill your statistical power with this. So you need tons of observations. In a way, it might be too conservative because maybe part of the seasonality that we're controlling for is actually part of the temperature shock, right? Maybe it's just harder to be pregnant in July. but we're stripping all that out and we're saying, no, it's only the additional temperature in July that we're identifying the shocks of. So in some way, this might actually be too conservative. We're killing too much of our statistical, we're over controlling. So that's kind of the problem with this method that you don't get when you take the percentile method that I was mentioning before. So it's not perfect. No method is perfect, but I like this more. The economist training in me where I just want to control for everything and then have like purely causal estimates that like appeals to me, but it's not appealing to everyone. Okay, let me check the time. When should I stop? 1:10?
Yeah.
Okay, I will. 1:15. Okay, I'll go through. Okay, so what we find here is we find, just like the Breck et al. Paper found, a negative effect of temperature that's kind of exponential with the higher temperatures. And we also find, so this is the concurrent temperature, so this is kind of like the people going into labor effect. So very cold temperatures and at very hot temperatures, we see an increase in the number of births due to what we think is like prematurity or people going into labor. And even though these figures don't look as striking as the Bereka findings, there's a difference in the x-axis. It turns out that once you aggregate to the effect of overall climate change, they're actually 5 times bigger than the Breck et al. Paper, which makes sense if you think that this is low and middle income countries, that they don't have as much AC penetration, they don't have as much ways to mitigate the heat, they suffer larger heat shocks. So that might not be that might not be surprising that the effects are bigger. And TFR is much higher in these countries. So whereas before I said, you know, maybe in the US it's going to fall from 1.7 to 1.68, which isn't that big of a deal. Well, maybe in Niger, where TFR is 7, it might fall to 6.5. So it becomes a little bit more substantive. Okay, I'm going to skip this paper. This is basically our work in Spain with 2 of my co-authors, but I'm going to skip that because I'd like to move on to some mechanisms in the remaining time that I have. Okay, so we want to figure out what fraction of this is caused by what underlying mechanism. So stillbirths is going to be really hard. Even if temperature does increase stillbirths, it's going to be really hard to detect this in a birth rate, like an overall aggregate birth rates, because stillbirths only make up 1% of all pregnancies. Miscarriages also only 18% of all established pregnancies. So, and since we also found these effects at 9 months, we think that the vast majority of the effect of what's causing these, the effect of temperature on births is going to be these kind of like very early, kind of like misconceptions or very early conception loss. But that's what we think, but it's really hard to measure that because this very early conception loss happens before women even know that they're pregnant. So how are we going to measure it? There are multiple ways of getting around this, but one of the ways is to look at sex ratios. So the idea is that males tend to be more fragile at any point in the life course. So, you know, more males are born than females, but by the time you get to 80-year-olds or 90-year-olds, there's a lot of women around and not very many men. So the idea is that it's also true in utero, and that males are just generally more fragile. So if you see some shock happen, and 9 months later, there's a drop in the fraction of males, people have inferred that that means there is this very early conception loss happening. So in one of, again, my PhD student, Yasmin, this is the first paper in her dissertation. She's looking at this with a set of co-authors. But she also looks not only at the spontaneous termination very early, but she also compares it to India, where she looks at induced abortion. Now, we don't actually have a measure of induced abortion because people usually don't tell us whether they induce an abortion, but we can look at the sex ratio at both in the first trimester and the second trimester. So the theory would kind of dictate that we should see conceptions being sorry, we should see less male conceptions after heat for both India and Sub-Saharan Africa, because those are the two regions we're comparing. But we should only see reductions at the second trimester in India because of changes in sex-selective abortion. And that's almost what we find. So what we find is that in the first trimester, there are reductions in Sub-Saharan Africa. There are also reductions in India, but they're smaller and not statistically significant. In India, we find reductions, but only in India. So this seems to align with the theory that temperature might be affecting women's propensity to sex select through making it harder to, if it's very hot outside, maybe they don't go to the clinic. And if they wait a few weeks, it's too late. And so these temperature shocks could have an effect on the actual realized number of sex selective abortions. Okay, another mechanism that a lot of people kind of think about when it comes to heat is sexual activity. So if it's hot outside, maybe you don't want to have sex as much because it's not pleasurable and that person is hot and you want them to stay away. There's no real direct test of this that's been done in the literature either. There is this cool indirect test though, which is if you go back to this bracket, this is another reason why I love this paper. They do it week by week, actually. So they can get gestational length and they can look actually at the week of conception, or at least inferred from the gestational length data. And they find that at the time of conception, there is no effect of temperature on births, but they find it a little bit in the preceding weeks, but mostly at 2 weeks before conception. So from this, that seems pretty strong evidence that it's not people changing their sexual activity, but rather that there's some sort of like health effect going on, where in the weeks before a woman would conceive, something happens that makes her less likely to have a birth. Maybe there's an interruption in the menses. Maybe, you can hypothesize a bunch of things. And it might not actually be like women's reproductive health, it could be men's, because 2 weeks, like there's spermatogenesis and it takes kind of 2 weeks to complete. So maybe, and we know that male sperm are very sensitive to heat. So maybe it could be affecting with the male sperm, but it seems to be that there's some sort of biological, like we hypothesize from this, that there's some sort of biological mechanism, not a behavioral one through sexual activity. Also, research on sexual activity is hard because people lie. It's taboo. People don't want to tell you about their sexual activity. So one of the other papers that I'm writing is we're actually looking at Google, because nobody lies to Google, right? So we have a different set of keywords that we're looking at and we're relating them to heat. So there are, this is the author set that I'm looking with that. So interestingly, lower temperatures increase searches for online dating. So here there might be a mechanism where it's affecting partnership behavior. So if you've ever heard of like people talking about cuffing season, right? It's cold and you want someone to cuddle. Here's some evidence, at least with the Google data, that searches for online dating fall in colder temperatures. Conversely, higher temperatures increase searches for pornography, maybe because you're substituting finding a person for a solo experience. Okay, another mechanism, contraceptive use. So this is a PhD student of mine that's at Max Planck currently. Her first dissertation paper is looking at temperature and contraceptive use. And I won't get too into detail on this because I'm running out of time, but there does seem to be a small negative effect of temperature on contraceptive use. When you dig into regions and methods, it seems to be solely driven by Sub-Saharan Africa and Latin America. And for methods, it seems to be solely driven by short-acting reversible contraception. Not surprisingly, Sub-Saharan Africa and Latin America are the two regions where those methods predominate, as opposed to, say, India, where it's sterilization. So that seems to line up. The paper hasn't yet been submitted. It's still a work in progress, so we may discover more things, but at least initially, that's kind of what we're seeing as happening. Oh, and so why? That's a good question. Why? We actually think it's through changes in sexual activity. So as temperatures go up, people tend to be less sexually active. So if they're using short-run reversible contraception, they just might not be sexually active anymore and then stop using that method for that reason. Okay, so conclusions. What do we know? Well, we know that climate change through temperature is likely going to reduce fertility. How much? Well, depending on the context, between 1% and 2%, or maybe up to 5 to 10%. We think that through these biological infecundity channels, that's likely. Through this, spontaneous termination, that's also very likely. Sexual activity, it kind of does look like it might change, but it doesn't matter for birth rates because of what we found in the Barreca paper. Is there a change in contraceptive use? It seems like there is some, but it's very small. It's probably not the main driver of this effect. And we don't know that much about partnership dynamics, which leads me to what is still to be done in this area. Well, I think that partnering behavior is kind of the big thing that is no one's done a lot on that, and it's also very hard to ask, because if you're looking at, a lot of partnerships take multiple years to start and, result in a cohabitation or a marriage or what other type of partnership you may envision. So it's going to be really hard to look at specific temperature or climate events and link that to partnership formation. At the same time, there are these very valid theoretical channels by which it may affect partnership behavior. So this is like a big question in the literature. Everything I've shown you is not completed fertility. These are period measures. So it could be, if there's recuperation, that all the effects I just showed you are zero, because people will just adjust fertility later in their lives. So we have no indication about how completed fertility is going to change. These are all period measures. Adaptation is a big question as well. So again, we're just looking at month-to-month changes. So if people adapt, this is also a big question in the literature. It's also, we don't really have a good idea of the specific physiological effects of heat on early termination, which seems to be one of the main drivers. Because we just don't know very much about very early pregnancy, right? So I've tried to meet with obstetricians, academic obstetricians, to be like, well, how would heat affect it? And they're like, we don't know, because we don't observe pregnancies in their third day. So there's very little, so we know that stuff happens very early on. We have this like 9-month evidence, but we don't actually know physiologically what's going on. So I'll stop there. I think I may have gone over a bit. But thank you very much. I look forward to your questions.
So thanks so much on the paper reference, what can you really say about people's actual experience? Because DHS clusters are set to try to be nationally also more representative. And so you get a lot of urban clusters, a lot of period clusters, where you have urban events, you have people who are spending more indoors and rural areas. And I don't think it was like it's quite a low temperature. And so, are you getting any systemic bias to the kind of heat exposure you're measuring? And are you overestimating results? That's one. And then the second is DHS doesn't have any good questions yet on adaptive. But if you've looked within the set of surveys that we've done and stratified them maybe on HPI or some other development indicator, so do you see any effect of capacity as moderating or accentuating the effects?
Yeah, okay, those are really good, important questions. So the first one, we don't have wet bulb. We're getting wet bulb. Oh my, how do I repeat that question? Okay. Okay, so the first question was about the temperature exposure and what we understand about how people are actually experiencing the temperature shocks that we measure in the DHS, and whether they could be heterogeneous by humidity or heat islands or those kind of things. The second question was about adaptive capacity and like doing interactions by HDI and other things like that. Okay, so the first question, I think all we can do is stratify by different, so we just have the temperature and we have the responses in the DHS. And if there's anything that's not captured, we can't run that in our analysis, but we can stratify. So we've stratified by urban rural, because we're thinking about this. It could be higher, the effects could be higher in rural areas if you think that there's food insecurity that causes like a maternal health kind of nutritional shock, or there could be heat islands where the same temperature shock actually is higher in urban areas. That's exactly what we find when we stratify. It's higher in urban areas. The effects are larger. So that lends evidence to the heat island idea. But again, that's just a theory. All we know is that when we stratify, we find it higher in urban areas. We're getting wet bulb, we don't have it. We do include humidity controls. So it might control some of that away, but I think that you're not getting out of control, you're getting at more that's the dependent variable, right? So we haven't done that yet, but we are currently in the process of getting wet bulb. Regarding adaptive capacity stratifying by HDI, we do stratify by income, which is not HDI, but it's kind of it correlates. And we do find that there are larger effects in low income and lower resource areas. Whether that's adaptive capacity or something else, we don't know. All we know is that we find that there's heterogeneous effects by these kind of like SES characteristics. Yeah. All right. Yes. Okay, I'm actually hard of hearing. So you looked at the equation, you want to know the rationale behind like a timing. Oh, the 15-month lag. Okay. Yeah, so she wants to know the rationale behind why we chose 15-month lags instead of some other lag structure. So Brecka et al., I think they did 24. We did 15 because I think we didn't see anything after, like we ran that regression, but we just saw a bunch of noise after 15 or so. So we just decided to cut them out of the regression, and we didn't see any of the coefficients in the earlier period change. So we kind of assumed that they weren't relevant. Now Brecka et al., they find stuff for those periods, but we didn't find anything statistically significant. So maybe they're there, but we just couldn't detect them because we are just killing all the power through all these covariates that we have in our regression. But yeah, there are theoretical reasons to think that it could go beyond 15 months. We just didn't find any detectable evidence that mattered. And then there's a second question. Okay. Okay, yeah, so her question is, when temperature changes, other things change like air pollution as well. And did we look at that? So we haven't done that in this paper, but I have a PhD student that's currently looking at air pollution. It's a very early project. And I think she's including temperature as a control. But going back to what you said, like whether things are controls or whether they should be included in the actual measure of a shock it depends on how you think about how the mechanisms work theoretically, right? So is humidity a control, or is it actually the thing that matters, right, for temperature? So currently it's a control, but I don't know exactly, I don't know the literature on how temperature affects air pollution as much, but I do know that it does. And so that should be taken into account. Yes.
Thank you so much. It's a really interesting talk. I was wondering if you could just say more. So am I understanding this right, that when you give us the 1 to 10% estimate impact on fertility rates, right? This is using some the SSPs, right, projecting to 2050 or 2100 or something?
Yeah.
And so I'm just thinking like about the word adaptation there with the question mark around it, and thinking about uncertainty, both in like the SSPs, which oftentimes we point to as coming from, oh, we don't know how we're going to respond, what are we going to do as a social problem. But also we have uncertainty about like generally what the impacts of climate change are going to be and where they're going to be located. So I guess thinking to your fixed effects model, do you have any concerns about like looking forward at cross-sectional tendency issues in terms of like accurate predictions for this, if that makes sense, and kind of assuming using fixed effects that you have all the years that matter already in there rather than having a population of years to sample from?
Yeah. So, yeah, that question is a long question. Yeah, so the question is about, so there's uncertain, so we're taking our estimates and we're taking the projections of climate change over the next 50 years to say this is going to be the effect of climate change over the next 50 years. But those projections themselves are subject to error, right? And so his question was whether we do some sort of, do we take that into account or do we do robustness? And then the other question was whether the years that we have currently, that we get these estimates from, are currently controlling well for the adaptation that might occur over the next couple of years. And climate change, yeah. So the answer to the second is no. We just have the birth histories, we have the time frame that those happen with, we include the fixed effects. What happens in the future, we aren't in the business of projecting. We also don't feel like we have the expertise to really question the projections and the assumptions over it. So we're just kind of taking those as given and saying, if those are given, this is what would happen. And those 1 to 2 or 5 to 10, those are based on the statistical error of our own estimates, not of the estimates of the climate impact. So a lot of times when people write papers on climate, they don't actually use this kind of like IPCC estimates. What they say is like, assume you had a heat wave of 5 days. And then they just take the coefficient and multiply it by 5, and that's nice and easy. It's just a way for people to kind of like benchmark how big the effect is in their mind. But we kind of like the real scenario, or the real projected scenario, as a better kind of like a way to benchmark it in your mind. But we don't look at any uncertainty around those examples.
Yeah, I'm really curious how it, sorry to keep going. I was really curious how it would change if you look at different SSPs.
Yeah, we haven't done that. Yeah. Yes.
Are you considering having I'm wondering with, I know it's a biological part, there's some, more determined in your sample might overcome those sort of relational aspects.
Yeah, so that's interesting because, okay, so first off, in the DHS, we have like the birth histories, and we construct those because we have a woman in the DHS who tells us when she had a pregnancy. So she could tell us her birth intention at the end, but we have a panel of 120 months. So we don't actually know what the intentions were at any given point in time. So we haven't currently asked that question, but I do know of a number of papers that have looked at that, at climate change and intentions. The majority show that birth intention, like people want to have less kids, but there are some studies which show either no effect or increases. So the preponderance of evidence says, I mean, that's how it is with many scientific questions, is you get answers all over the place. But most of the papers I've seen have shown negative effects, but it's still a good question, still an open question, I think.
Thank you so much. That brings us to time. What a fascinating topic and really